Okay, review videos part 2. So we're going to look at kind of 6.2 through 6.4-ish. It's all just about the types of centers in a triangle. So there are 4 that we talked about. The ortho center is really kind of the one that is just kind of there. There's not a whole lot special going on. But if we look at each of these, the first one is the circumcenter. And what we want to be looking for in the circumcenter is perpendicular bisectors. And so I see that it's a perpendicular line and it cuts it in half. I don't care if it's going to the vertex or anything. I'm looking for that perpendicular line and it being cut in half right there. So as we move the circumcenter around, it is inside. It can also be on the triangle. It's on the triangle, on a right triangle. But then it can also be outside the triangle. I don't know, choose triangle. This is kind of a good way to see what's going on here. So if you look at, as I move A, this line right here doesn't move. And that's because BC is right there. So if I move A around, it just goes up and down on that line OP, because that line doesn't move. My perpendicular bisector doesn't move for that. But what we often confuse this with is the orthocenter. The orthocenter is just perpendicular lines. Orthocenter can be inside, it can be the vertex of that, and it could be outside. But notice how it's still perpendicular, but what's different about this one is it's perpendicular, but it's not bisecting. How we decide where the line is it goes to the vertex. So if you see perpendicular lines that go through the vertex, it's the orthocenter. Then our other 2 ones are the incenter. The incenter is created by angle bisectors. So we should see angle bisectors right here and right here. And again, this is one that doesn't go through the vertex. But what we see is that this point is going to be the same distance to this line. This is the same distance to each side. If no matter where we move this, it always stays inside though. And then we have the centroid that goes from the midpoint to is created by medians. Then it goes from the midpoint to the vertex. And so it's always inside because that's just the creation. A lot of you guys said it stays in the same spot. We want to be careful with that, but I'll talk about what this does in a second. But a lot of people will get this one confused with the incenter because it looks like it's inside. But these 2 down here go through vertices, where these 2 are created by perpendicular bisector and angle bisector. And so we can kind of look at the differences in those. But then the equations that come from those, the equations that are important, is that the circumcenter is always going to be the same distance to each vertex. And that is because of the perpendicular bisector. Remember, any point along this line is the same distance between these 2 vertices. And so I can move this, and it's the same distance to each vertex. And so we have that same equals. We can use the equal sign between the distance from the circumcenter to the vertex. The incenter, if I put a point there at the incenter is the same distance to each side. And so here, if I take E, I'm not going to go to that point, but I'm going to go to that line. I'm going to go to the line. Sorry, I need to select the point. I'm going to go from this to that line. I'm going to go from this to that line. And that's that perpendicular distance. And notice how they're all the same. No matter where I move this, they're always the same distance to the side. And that's because the angle bisector is always the same distance from the side. The centroid was the interesting one. The centroid one was the one that we struggled with a little bit. But the key things that I want you guys to see with the centroid is that the distance from the midpoint to the centroid is half the distance from the centroid to the vertex. Is an important word there. It's half. This is half of that size. And so we can use that is as an equal sign. We can say 1.2 is half of that. I think it's a little bit easier to say this is double than that one. But we can also look and say this is 1/3 of the entire thing. Because if I go the entire length from Z to H, it's 3.7. Rounding issues 3.6. But no matter where I move these, it'll always kind of be that same idea. This is half of this, and this is 1/3 of that. That's what the centroid is going to do. That's the equation that you guys are looking for. The orthocenter is just cool because it's a point of concurrency. There's nothing truly special besides like what I said before. It's the point of a point on the Euler line, which I'm not that worried about, and I don't think you guys should be either. So we will look at that, but these are the four centers. You have the circumcenter, created by perpendicular bisectors, same distance from each vertex. The incenter, created by angle bisectors, and it's the same distance from each side. You have the centroid, also known as the center of gravity, which is the same distance, the centroid, which is the same as center of gravity. And the distance from the midpoint to the centroid is half the distance from the centroid to the vertex. And then you have the orthocenter, which is created by altitudes, and it's just there, it's created by altitudes. So make sure you guys are looking for those things when you're identifying which one is which. I might suggest writing down a table saying circumcenter, what is created by, what's special. Incenter, what is created by, what's special. We kind of had that table on a different segment as well. So again, I'm going to post this video. I'm thinking I have mid-segment and another one, 2 more videos that I will post that will kind of help you review. And I'll be on from 1 to 3 to ask any questions that you guys have.